Let's talk about how to use t-tables, also known as like input-output tables. So this number one right here, we'll just do one example. It says complete the table for the radius versus the area of a circle. So first off, we need that actual formula. The area of a circle is pi times the radius squared. So what we're going to do first off is we're going to complete this table. We're going to plug in the different radius values that we're given. And normally on these tables, we can actually pick the radius values, or we can pick the input values we want to. We're going to find the areas that go along with them, and we're just going to finish this table out. When we plug in a value, radius value of 0.5, so we're going to do pi times 0.5 squared, we actually get a decimal of about 0.78. We'll call it 0.8. When we plug in a radius value of 1, we get pi times 1 squared, or pi times 1, which is 3.14. It's actually pi. We'll call it 3.1. When you plug in a radius value of 2, you square it, multiply by 5, you get 12.56. We'll call it 12.6. And when you plug in a radius value of 3, you square it, multiply by pi, you get 28.26, I believe, which is about 28.3. Now, the next thing we need to know is inputs and outputs can be graphed on a actual XY coordinate axis, or a coordinate graph, a coordinate plane. So these are inputs and these are outputs. Let's show you how to graph them. The first one, 0.5 comma 0.8. The input value is 0.5. And notice what I did with my scales here. Every other box is going to count 1. So therefore 0.5 is going to be right in the middle. And I let all my y values jump up by 3 because of the scale here. So when I plugged in 0.5, I got nearly 1. So 0.5 comma 1 is going to be somewhere right along in there. When I plugged in 1, I got a little bit over 3, which is going to be about right there, 3.1. When I plugged in 2, I got 12.6. So at 2, I'm going to go up to 12.6, which is going to be just a little bit past 12. And then when I plugged in 3, I got a value of 28.3. So I'm going to have to go up a little bit further, 24, 27, 30. So when I plugged in 3, I got a value of about 28.3. You can connect your dots here. If you were to plug in 0, you would get 0. But the thing about it is, we need to talk about a little bit about domain and range here. Let me do a smoother graph right there. There we go. We would never plug in negative values, and actually a radius can't be 0. You wouldn't even have a circle if it's 0. So I'm actually going to put an open dot right there. And if we were to talk about inputs and outputs, or domain and range, your domain values, the things that you can actually put into this to actually see what the area would be, would have to be values larger than 0, not equal to 0. So my input values here would be all values, and we can go ahead and write in this notation. Any value from 0 to infinity I can put in, and you'll never get an area value of 0, so my outputs, or my what we call the range, would also be all the values from 0 to infinity.